Hey all, Rusty Rob here. Welcome back to Advent of Code. And in today's day 18, I managed to get around 500th place. So I was pretty happy with that with Rust. So just go through the solution. It was a pretty straightforward solution, kind of brute forced it. But yeah, so you got a raindrop. And so the raindrop is represented as a bunch of X, Y, Z coordinates. So in 3D, but let's just pretend this is our raindrop here. And we have to work out the surface area of the raindrop. Uh, but it's a little bit more complicated because there can be air pockets inside the raindrop. I don't know if it's a raindrop or if it's a lava drop or something like that. But anyway, so I basically just looked at, I made a square or a cube around the outside of it. And I just fill that in, just brute force, keep filling it in. And yeah, just filling it all in. So, and I just call this set outside. And I also have a set of the interior. And so then all I can do is just go through every single point inside this total square, which will just give me all the points inside as well. And for each of these, I can check, is it matched up against uh, a value from the set? And if so, then I don't count that towards the outside surface area. And yeah, that's pretty much the answer. So let's go through the code quickly. So what did I do? I just used a string for the input. I'll just go to presentation mode. And I managed to code this up in maybe a bit under 20 minutes. But yeah, I used the point struct and then I implemented the Manhattan distance for that. And then I made this from trait so I could grab that point from a vector. And then in my main method, I use a regular expression to get the numbers out and just collected those into a vector of I64. And then, so from that, those three numbers, I grab a point and I add that point to my list of points, but I also go through all the other existing points and just check the distance. If it's distance one away, then we increase the number of pairs. And then what is this code doing? So here I just grab a set of all the points we have, which are part of the lava drop. And then I'm making this set for the outside. So I just did some maxes and mins on the on all these x, y, z coordinates, and I saw the minimum was always 0 and the maximum was always 21. So that meant I could just go -1 and 22 as my outside. So just brute force it basically, go through every possible point and just check if it's on the outside. Then I add it to the outside set. And I just loop forever while we're not done. So I say, so I'm going through all the interior points and yeah, create that point. Uh, and if we already have that as an input point or if it's already on the outside, then we just continue. Otherwise, I go through every point on the outside, and if it's connected to the outside, then it's an outside point. So yeah, then I just add it to the outside, and done equals false. And eventually, we'll stop adding points to the outside, and then done will be true, and then we'll break. And then what did I do? I just wanted to count how many bad pairs there were. So looking at all possible points within the air pockets. So just brute forcing all the possible points, and if it's not part of the lava drop, if it's part of the drop, we continue. If it's part of the outside, we continue. Otherwise, we know we're on the inside, so we're in one of the air bubbles. And then I just go through all the interior points and just check the distance as one. And if it is, then uh, then it won't count. And then the answer is just the number of points multiplied by 6, because yeah, each cube has 6 faces. And then we subtract the number of pairs times 2, and we subtract the bad ones because they don't count. And that was the answer. So yeah, a quick, easy one. I thought that was pretty fun to whip up. If you want a more efficient solution, you could just, I guess, do a breadth first search from the outside. There's a few different ways you could solve this one. But yeah, hope you all enjoyed it, and see you next time.